Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices and calculus. Today, we are going to discuss the topic on the eigenvectors of the matrix. Eigenvectors of the matrix. In the last session, we discussed from the given matrix how to find the characteristic matrix, characteristic polynomial, characteristic equation, and how to find the eigenvalues. That means, before here, if we want to find out the eigenvectors, first of all, we need to understand that what is the eigenvalues, and before that, what is the meaning of the characteristic matrix and characteristic polynomial, characteristic equation. That we need to discuss, first of all, here, again, that what is the characteristic matrix or characteristic equation. How to find the characteristic equation? Because of when we are going to find out that eigenvectors, we need to find out that eigenvalues is must and should. And based upon that eigenvalues only, we need to find the eigenvectors. Without finding the eigenvalues, eigenvectors are not possible. Therefore, first we need to find the eigenvalues. And for the purpose of the eigenvalues, here we need to understand what is a characteristic matrix, characteristic polynomial, characteristic equations. Here, for example, here when we are going to finding the characteristic equation, that means, for example, if the matrix is considered A is any matrix, for example, I consider here the 3 by 3 matrix. One is A11, A12, A13, and second row A21, A22, A23, and third row A31, A32, A33. This is the square matrix. Based upon the order of the matrix is 3 by 3, be a square matrix. And let us assume that I is any that suitable the matrix corresponding the 3 by 3. That is unit matrix of order 3. It is 1, 0, 0, 0, 1, 0, and 0, 0, 1. This is an identity matrix, and also where lambda is any scalar. And with the help of this A lambda I, if it is treated in terms of A minus lambda I, that means within the box, that is a matrix notation, A minus lambda I is called the characteristic matrix. That means the characteristic matrix. That means the matrix is obtained in the matrix notation only. Based upon it is also characteristic matrix by the consider A and lambda and I matrix. And here next to what is a characteristic polynomial. That means whatever we consider that matrix A minus lambda I, and with the help of that, if it is finding the data, that is a polynomial terminology. That means the data of A minus lambda I is called the characteristic polynomial. That means what with the help of the matrix only we obtain the polynomial. That is the second stage. And with the help of the data of A minus lambda I, if it is equating 0, that means it is a characteristic with the help of the matrix and polynomial characteristic equation by equating 0. That means the characteristic equation of the matrix is equal to the data of A minus lambda I is equal to 0. And here further we need to find out by using this the data of A minus lambda is equal to 0, we get the by solving that equation, then we get the values. That values are called, that is a characteristic values or eigenvalues. And here, for example, the matrix, the characteristic matrix. That means whatever we define the definition, that is with the help of the A, B, N square matrix of order n, and then the matrix A minus lambda is called, that is a characteristic matrix. For example, 2 by 2 matrix. Let us assume that here A, B, N matrix 1, 2, 3, 4, and again that is box of A minus lambda I, with the help of the lambda is any scalar, and again that then that the box of A minus lambda is equal to 1 minus lambda, 2, 3 minus 3, and 4 minus lambda I is called the characteristic matrix, because of we obtain in the terminology of the matrix. That is the meaning of characteristic matrix. And characteristic polynomial. Further based upon the polynomial, that matrix only we obtain the polynomial. That means the data. When we are going to finding the data of A minus lambda, that means again let A be any square matrix of order n, then data of A minus lambda is called the characteristic polynomial. Same, for example, the matrix is A is equal to 1 minus 2 and 4 1. That means data of A minus lambda I. As we know that whatever the data of this matrix, that is a 1 minus lambda minus 2 and 4 1 minus lambda. This we need to find out the data. That is, as we know, the 2 by 2 data is a AD minus BC. Therefore, with the help of the AD minus BC, we obtain that is a polynomial terminology. That values are called, it is a characteristic polynomial. But here, it is order of the matrix is a 2. Therefore, the polynomial is also we occur, that is a second order. And again, similarly, for example, what is the characteristic equation? Based upon the definition of the data of A minus lambda I is equal to 0. That means, let us A be any square matrix of order n. Then, by equating that polynomial that is equal to 0, that means data of A minus lambda is equal to 0, we obtain the equation. That equation is called the characteristic equation. For example, let us consider this matrix. As we know that already we find out that is a lambda square minus 2 lambda plus 9. By equating is equal to 0. That we get the equation is called as a characteristic equation. And these are the one by one interlinked. One is a characteristic matrix, characteristic polynomial, and characteristic equation. And here, in previous session, we discussed the eigenvalues. That means here with the help of that characteristic equation, by solving the values are called the characteristic values. Here, for example, how to find the characteristic equation under the 2 by 2. These are the already we discussed in the last session that how to find the eigenvalues. And here also we need to further continuation of the eigenvalues. We find the eigenvectors. And again we need to recall today class. It is again that what is a characteristic equation. Here under the 2 by 2 and also under the 3 by 3. And again these are the some shortly method here to find the characteristic equation by for finding the values of the eigenvalues. And here under the 2 by 2, here it is a polynomial equation is a second order, and again the 3 by 3 the polynomial equation is a third order. That means it is a second order, that is a lambda square minus 2 lambda square minus s1 lambda plus s2. And moreover, that s1 is equal to clearly given, that is a sum of the diagonal elements. That means sum of the principal diagonal elements. And again that sum of the principal diagonal elements, sometimes it is a trace of the matrix. And S2, that S2 is nothing but it is the determinant of the matrix. And here I mentioned that it is a dead directly, but it is also sometimes it is S2. That S2 is nothing but the data of the given matrix. And similarly, coming to find that is a 3 by 3. Under the 3 by 3 also, it is a 3 by 3 means the third order polynomial. Under the third order polynomial, it is a required lambda. The lambda cube minus that is a s1 lambda square plus s2 lambda minus s3 is equal to 0. And where here s1, s2, s3. That s1 is nothing but that is a sum of the principal diagonal elements. Same like that, that is a trace of the matrix. And s2, that s2 is nothing but the sum of the minus of the order of the 2, that is a diagonal elements. That means the minus of the principal diagonal elements you need to find out. And after finding, we need to addition of the 3 values. That is a meaning of that S2 is a value. And S3 is equal to, same like under the 2 by 2, that S3 is nothing but it is a trace of the matrix. And sometimes here also it is nothing but denoted, that is a S3. And these are the some short method to find the characteristic equation from the 2 by 2 matrix and also the 3 by 3. In other terminology, that is a lengthy process, that is to finding the simplification, that is a data of A minus lambda is equal to. As you know that under the 2 by 2 and 3 by 2, how to find that, that is a data of the given matrix, the data of A minus lambda, that is a characteristic equations. And further, we need to discuss, that is a working rule. Again, we need to recall. According to when we are going to find out the eigenvectors, first we need to find out the eigenvalues. And again, the purpose of that is a working rule under the finding the eigenvalues. Here, write the characteristic equation first step. That means we need to find out from the given 3 by 3 or 2 by 2. But here, I am going to discuss that is a 3 by 3. And based upon it is a 3 by 3 is a lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. And we need to find out the values are s1, s2, s3. As we know that, what is the meaning of s1, s2, s3? And again, recall that s1 is a trace and S2 is the sum of the minus of the two order of the diagonal elements, and S3 is the trace of the matrix. And again, similarly, we need to find out and find the after finding that S1, S2, S3, we need to replace in the Gauss equation. And again, here we obtain the values are here lambda 1, lambda 2, lambda 3. That means by finding that because of the matrix is a 3 by 3. While we are going to solving the 3 by 3, we obtain the three roots. The three roots are nothing but it is treated as lambda 1, lambda 2, lambda 3. Here these are called as the eigenvalues or characteristic values or latent roots or proper values. And similarly, here these are the eigenvalues lambda 1, lambda 2, lambda 3. And further, we need to find out here the continuation today class, we need to find out what is the eigenvector. The step of that eigenvector is nothing but, for example, lambda 1, lambda 2, lambda 3 are the three eigenvalues. We need to find out the three eigenvectors by taking that L1 with the help of the formula. Solve that equation, that is system box of a minus lambda 1 into x is equal to 0. And after finding that, we find that by using either the equation method and also that is a Gauss elimination method. That means here raising the two methods are also. And again, we need to give the priority like equation format. And moreover, the Gauss elimination is also possible days. But here it will, I'm not going to discuss that like particularly Gauss elimination. That is also possibilities are there. And again, but here easy calculation purpose, I'm going to follow like equation method. And again, after finding this is the equation method with the help of data like box of a minus lambda 1 into that is I into x is equal to 0, we obtain that corresponding lambda 1, that eigenvector of x value. That is the first eigenvalue, eigenvector. And here x is the non-zero like variable, that is x1, x2, x3 or sometimes xyz also. That is a x is a vector. And similarly, and we need to find out that further lambda 2 and also lambda 3. Like that, the number of eigenvalues are there. We need to require to find out that is a different eigenvectors that depend upon the given getting the eigenvalues. And again, step 2 and again like this is the meaning of step 2 repeated for the lambda 2 and lambda 3. Okay, this is the working rule clearly. Here we need to find the eigenvector. That means we need to find out what is the equation, the main concept, and again finding the eigenvalues and corresponding eigenvectors we need to find out with the help of first is a delta of a minus lambda is equal to 0, and again by using the short method or other any method, and corresponding eigenvectors box of a minus lambda 1 into x is equal to 0. And similarly further we need to find that lambda 2 and also lambda 3. For example, we need to discuss like problems. First method, find the eigenvalues and corresponding eigenvectors of the matrix. And moreover, in the last session, we discussed like these are the problems based upon the finding the eigenvalues. But now today class, we are going to discuss that eigenvectors. But anyhow, we need to find the eigenvectors. First of all, we need to find out whatever that eigenvalues also. And again here, the matrix is that here, this is the 3 by 3 matrix. And based upon this 3 by 3, and again here I am going to discuss the first method, first one. Again we need to recall, and continuation we need to find the eigenvector. Here, as we know that, how to find the eigenvalues. And again, according to that, we know that characteristic equation, the delta of a minus lambda I is equal to 0. And delta of a minus lambda is nothing but here again, this is the meaning of delta of a minus lambda. That means we need to subtract from the diagonal elements. That means these are the diagonal elements. Subtraction like with minus lambda. That is the meaning of delta of a minus lambda. And again, with the help of this one, as we know that, what is the delta of this 3 by 3 in beginning level, in the basic level, we know how to find the solution. That means, for example, it is the first one into after deleting the row and column, and again that second, and again here 7 minus lambda, 3 minus lambda, minus that 4 into 4 like that. We obtain that this is the method, and again minus of minus. That is a like a simplification process, as we know that how to find out. And again here, after the total simplification, this equation is nothing but this is the after take out common lambda, we obtain this the equation. And why we need to find the solutions. That means first one is a lambda is equal to 0, and second one is within the bracket that is also 0. And here that one is eigenvalue 0. the other eigen two eigenvalues by finding these are the values. In the previous lectures we discussed briefly, and again it is nothing but lambda is equal to, from this second equation, the order of the 3 comma 5. That means entirely here the eigenvalues are 0 comma 3 comma 15. Therefore, after finding these are the eigenvalues, because of here the 3 by 3 matrix, and again we obtain the 3 eigenvalues. And further, again we need to recall that is the second method to find the eigenvalues. Again, what is the method of the second method? That is shortly, that is according to 3 by 3. First, we need to assume that there is a box of a minus lambda is, that is delta of a minus lambda is equal to 0. The characteristic equation, as we know that. And again, the method is lambda q minus s1 lambda square plus s2 lambda, and again minus s3 is equal to 0. And here, under here, we need to find out what is s1. That already we discussed briefly in the previous session. Again, we need to find out further. Because of the purpose of the eigenvectors, we need to find out the eigenvalues also. And again, here S1. That S1 is nothing but it is a meaning of trace of the matrix. And here trace is nothing but whatever the diagonal elements in the given matrix. The diagonal elements are, it is a 8, 7, 3. That means the trace is nothing but 8 plus 7 plus 3. Therefore, the value it is equal to 18 is a value. This is the meaning of the trace is nothing but that is a sum of the principal diagonal elements. And again S2. That S2 is equal to the sum of the minus of the principal diagonal elements. The sum of the minus of principal diagonal elements. And we need to find the sum. But we need to find out first is the minus of the principal diagonal. Here principal diagonal elements are, as we know that 8 comma 7 comma 3. That particular 8 eigenvalue is a principal, that the 8 element is a principal diagonal element, that is a minor. That minor is nothing but that particular 8 is the first one. It is a delete that particularly row and column, and again the rest of the values are 7 minus 4 minus 4 3. That particular is we need to find the, that is the meaning of minor, that find the dead value. And again second one, the principal diagonal element, second one is a middle of the value of that. The given matrix is a 7. And again the 7, the minor. And again here also we need to eliminate that particularly row and column. That means the rest of the values are 8 to 2 and also 2, 3. That value we need to replace here. And next further, the third value of in the principal diagonal element is, that is a 3. And again that 3 particular eigenvalue is a minor is a delete that particular row and column, and again the rest of the values are, that is 8 minus 6 minus 6 7. That value we need to find out the sum. That means these are the 3 are the particular the minus of the diagonal elements, but again we need to find out what is the sum of these 3 terms. Therefore we need to addition of the sum, and we need to find out that particularly the 2 by 2 dead value. Here 1 by 1 it is a values are 5, 20, 20. Therefore, the sum is equal, that is a S2 is equal to clearly 45. Therefore, S1 is a 18 and S2 is equal to 45. And further, we need to find out what is a S3. That S3 is nothing but that is a given matrix, particularly the data of the matrix. Therefore, the data of the matrix of that given matrix is a, after finding that, as we know that how to find the data, the value of the data is nothing but it is a 0. And based upon these are the S1, S2, S3, we need to replace in the required characteristic equation. Therefore, the characteristic equation is nothing but, as we know that this is the characteristic equation lambda q minus S1 lambda square plus S2 lambda minus S3 is equal to 0. While we are already we got it, that is S1 and S2 and S3, and these values we can replace in this equation. Therefore, here S1 is equal to, we know that 18, and S2 is equal to 45, and S3 is equal to 0. These values we can replace in the lambda cube, that is the third order equations. And again, therefore, after replacement of here, lambda cube minus 18 lambda square plus 45 lambda is equal to 0, because of S3 is equal to 0. And further, we need to solve these equations. Here, as we know that how to find the characteristic equation, that is a third order equation based upon either the synthetic division or factorization method, we obtain the values are clearly lambda is equal to 0, 3, 15. These particularly 3 values are called, that is the eigenvalues. And even we need to cross verify with the help of the brief method also, we obtain these are the eigenvalues. By using these are the second method, that is short method, we get the values are 0, 3, 15 is the final solution. And further, we need to find out how to find the eigenvectors that corresponding lambda is equal to 0, lambda is equal to 3, and lambda is equal to 15. For example, here the Karski equation, these are the factorization method, that is synthetic division method. Lambda is equal to 0, 1, 1. This is also like factorization, that is our choice to find out according to that depend upon our convenience, either the factorization method or any other synthetic division, we can find the solutions. Here the rest of the equation is 1 into lambda square minus 18 into lambda plus 45 is equal to 0. And again we need to find out what is the equation of the second order. By equating the second order equation also we get the 3 comma 15. Therefore the final solution it will be, here again further it is factors into dividing into process, the lambda is equal to 0 comma, that is 3 comma 15. These are the particular eigenvalues. That means that our choice we need to find out that eigenvalues either the shortly and also either the briefly or any other method, we need to find the solutions. Yeah, these are the particular eigenvalues. And based upon this continuation, we need to further proceed in that what is the eigenvectors. The eigenvectors are nothing but here corresponding the character like eigenvalues, lambda 1 is equal to lambda 2 is equal to lambda 3. That 3 cases we need to find out the corresponding here, because of the eigenvalues are it is 3 different eigenvalues. We need to find out the 3 different eigenvectors. And again here, as we discuss given the definition of the eigenvector, that is corresponding that lambda value, that is a minus lambda 1 into x, I is equal to, that is into x is equal to 0. That we need to find out the case 1, and case 2 is equal, that is lambda is equal to 3, and case 3 is equal to lambda is equal to 5, 15 for it. And again, for example, the solution finding the eigenvectors, already I am given the definition for this, that is a corresponding eigenvector here in presence of a minus lambda into x is equal to 0. But as we know that here these are the 3 cases we occur. One is the lambda 1 is equal, that is 0, and lambda 2 is equal, that is 3, and lambda 3 is equal, that is 15. And first we need to replace at lambda is equal, that is here lambda is equal to 0 case. And while we are going to replace in this a minus lambda into x is equal to 0, here clearly that replacement of lambda at is equal to 0. Therefore, the first row is 8 minus 6 2. And second row is minus 6 7 minus 4 and 2 minus 4 3, and these are the matrix after replacement of lambda is equal to 0 in this matrix. And x is nothing but x1 x2 x3 is assumed that it is a non-zero vector, and is equal to, that is 0 is nothing but 0 is vector corresponding that 1 0 0 0, and this is the matrix. Now here I am going to discuss according to by using the equation format. That is our choice by using the Gauss elimination method or any other method. But I am going to give the priority for that. That is a Gauss like equation format. While we are going to discuss by using the equation format, here we need to first of all write in the equation format from this matrix. One is a first row is 8 into x1 minus 6 into x2 plus 2 into x3 is equal to 0. And again here the second equation minus 6 into x1 plus 7 into x2 minus 4 into x3 is equal to 0. The third equation it is a 2 into x1 minus 4 into x2 plus 3 into x3 is equal to 0. These are we obtain that these are the particularly 3 equations from these are this one is a matrix. And while we are going to observing in these here, we need to take any 2 equations by solving that for solving the eigenvectors. For example, here whatever we are going to choose the 2 equations, it is a must and should it is satisfied the 2 different equations. For example, if it is treated as like the 2 same equations, for example, while we are going to solving, that is eigenvector values are 0 0 0. That means we need to understand whenever solving the 2 equations by taking any 2 equations, if we get for example the values are 0 0 0, that is x1 x2 x3 is the values are 0 0 0, that means we need to understand the equations are it is a not a correct equations we are considering, because of here always the eigenvector is a non-zero eigenvector, that is required to satisfy all the eigenvalues are like eigenvectors are it is 0 is not required. Therefore that we treated what we treated the equations are, if we get the eigenvector is 0 0 0, that means we treated the equations are it is a not correct. Therefore we need to understand properly whatever we are going to take, the equations are two different equations we need to consider. Here we should not take that any repeated equations, and based upon that, here I am going to selecting in this problem the three equations are same. Sorry, the three equations are different. That means we need to take any two different equation, either the first second or first third or second third. By taking any two equation, we get the same the eigenvector. We should not get that any same repeated different eigenvector. That is we need to understand. Here I'm going to select that second and third. For example, here under the second and third, that means we need to assume that any first and second or first and third is also no problem. But I took that it is the second and third because of the three equations are the different equations. And here by taking the second and third, here what is we need to observe that the first row, second, that first column, second column, third column, like that repeated. We need to understand properly here that x1 coefficient is 8 and the x2 coefficient is minus 6. So, and sorry, in the second equation, the x1 coefficient is minus 6 and x2 coefficient is 7 and x3 coefficient is minus 4. That we need to consider according to this x1, x2, x3, and x1 is also we need to consider. Why we are going to consider means just we need to observe here. And x1 coefficient is the second equation, that is minus 6, and again x2 is a 7 and x3 is equal to minus 4, and we need to consider one more, that is x1 is equal to that is minus 6. And here the third equation, for example, why we are considering the third equation also, and based upon the third equation, it is x1 coefficient is 2 and x2 coefficient is minus 4 and x3 coefficient is 3, and further that x1 is that is also 2. Like that we need to consider any like first, second or first, third also no problem, that we get the same solution of according to by taking this one. Here after consider this one, here we need to find out what is x1 by x2 by x3 by, for example, x1 by, and what is the meaning of this x1 by. While we are going to observe here that x1 is nothing but we need to close this one, that is this one. The rest of the values we need to consider, that is 7 into 3 minus it is minus 4 into minus 4. That is the meaning of we get that x1. That is the meaning of here 7 into 3 is 21 and minus that is BC is nothing but minus into minus is a minus 16. Therefore 21 minus 16. And further if you are going to consider that is x2, and same this concept, it is while we are going to finding that x2, here we need to close this is these two, this is the one part, and rest of the values we need to consider at the time of that x2. It is minus 4 into 2 is nothing but it is a minus 8, and again here it is a minus half, that is a 3 into that is a minus 6. That means we obtain that minus 8, and again minus half minus is nothing but plus 8. This is that is by taking the x2. And again for example x3 by means while we are going to find out here x3, after that x3 there is no other term, the right side. Therefore, we need to come to that is a left side. It is also minus 6 into that is a minus 4, that is a 24, and again minus the 2 into that is 7, that is also minus 14. Therefore, based upon this x3, we need to find out according to these are the two conditions. And again is equal to, we need to assume k is any arbitrary constants. And after getting these are the x1 by x2 by x3 and is equal to k, and we need to simplify in the denominator. That x1 by the 21 minus 16 is a 5, and again x2 by denominator is also like that minus 8 plus 18 is a plus 10, and again x3 by the 24 minus 14 is a that is also clearly 10 and is equal to k is a 1. And further we need to cancel that division denominator 5 10 10 is nothing but divide with 5 ja, that is a 1 5 1 ja 5 2 ja 5 2 ja. Therefore here we get that it is after that x1 and again x2, that is a 5 2. Therefore x1 is equal to 1k is nothing but it is a k, and again x2 is equal to that is a 2k. Therefore and again x3 is equal to also the 2k, and therefore these are the eigenvector corresponding that lambda is equal to 0. Therefore we need to assume that it is considered that is eigenvector is that is corresponding lambda is equal to 0, that 1k 2k 2k is equal to 1 2 2 is a corresponding eigenvector, like corresponding eigenvalue of lambda is equal to 0. This is the eigenvector. And same like this process we need to find out it is a lambda is equal to 3 and lambda is equal to 15. And here for example that second eigenvector, similarly lambda is equal to 3. And here lambda is equal to 3, the second eigenvector. Same here also we need to replace lambda is equal to 3 in that 8 minus lambda and 7 minus lambda and 3 minus lambda. Here while we are going to replace the lambda is equal to 3, the matrix is reduced to 2, that is a 5 minus 6 and again 2 minus 6 4 minus 4 and 2 minus 4, that is a 0 and again x1 x2 x3 is equal to 0 0 0. Now again we need to write in the previous lambda is equal to case, and here also if it is treated in terms of like that equation format, the first two it will be 5x1 minus 6x2 plus 2x3 is equal to 0. The second equation is reduced to minus 6x1 plus 4x2 plus minus 4x3 is equal to 0. And similarly we need to consider what is the third equation, that is a 2x1 minus 4x2 plus 0 and x3 is equal to 0. These are the three different equations. Here also while we are going to observing, these are also the three equations. And here also our choice, you need to take that any second third or first second or first third, because of all the three equations are the different equations. Here also I choose that is the second and third equation. Therefore based upon this, it is a x1 coefficient is, that is x1 coefficient is a first one, second one, third one. Here x1 coefficient is a minus 6 and again x2 is a 4 and x3 is equal to minus 4. Minus is x3 is equal to minus 4 and x1 is equal to once again that is a minus 6. And further the third equation, the coefficients are x1 is a 2 minus 4, that is 0, and also the 2. And based upon this one, these two equation, again we need to find out what is that x1 by x2 by x3 by is equal to k. That means here x1 by 1 means that is a 4 into 0 is a 0, and again it is a minus of minus is a minus, that is a minus 4 into that is a minus 4, it is a 16, but minus is existed 0 minus 16. And similarly that x2 by means that is a minus 4 into 2 is a minus 8, and again minus 0 into minus 6 is nothing but it is a plus 0. And x3 by means here the rest of the right side is not at all any columns. Again we need to find out minus 6 into minus 4 is that is 24, and again minus 2 into 4 is minus 8. Therefore is equal to equal the k value. And again we need to simplify the denominator, that is x1 by minus 16 and again x2 by minus 8 and x3 by 16 is equal to that is a k. And further it is also possible is like division with 8 and again including it is a minus 8, the values are it is clear because of minus 8 into 1 and again minus 8 into minus 2, that is a plus 2, and again x3 is equal, that is a minus 2. That means that x1 is equal, that is 2k, and again x2 is equal to that is a 2k, and again x2 is equal, that is a k, and again x3 is equal to minus 2k. Based upon that, by taking any k is any real value, we get the eigenvectors of the corresponding particular lambda is equal to 3 is the eigenvector. Therefore it is lambda is equal to 3, the eigenvector is the 2 1 and also minus 2. And further one more it is also required, what is the eigenvector corresponding that lambda is equal to, that is a 15. And similarly if it is considered based upon this the matrix of this, and again here also lambda is equal to 15, and we need to replace lambda is equal to minus 15. And therefore here also after replacement of lambda is equal to minus 15 in place of the lambda is equal to 15, therefore we obtain this the matrix. And further again we need to treat it as in the equation format, as we know that the first equation is minus 7 minus 6x2 plus 2x3 equal to 0. The second equation minus 6x1 plus minus 8x2 minus 4x3 equal to 0. The third equation 2x1 plus minus 4x2 minus 12x3 is equal to 0. And based upon this one, again while we are going to observe here, the three equations are the different. This is also our choice, either the first equation, second equation, or first and second, or second and third. Again I am going to treat same like the second and third. That is our choice. We need to assume that any first second also we get the same, and second first third also we get the same values. And again here the second equation, the coefficient is minus 6 minus 8 minus 4, and again the minus 6, and again x3 is after row is 2 minus 4 and again minus 12, and again this is also 2 value. And again further x1 by and again x2 by x3 by, therefore again we need to simplify further. The first one is x1 by it is 80 and x2 by minus 80 and x3 by 40 is equal to kVLE arbitrary constants. And again here the division with 40, then the first value is x1 is equal to 2k and x2 is equal to minus 2k and x3 is equal to that is a k is a value. By taking any k, any real like a real value, that is x1, that is x3 is a eigenvector corresponding lambda equal 15. The values are 2 minus 2, that is a 1 is a final solution. These are the clearly we need to obtain that eigenvectors corresponding that lambda is equal to 15. Like that, any problem is given. Further, we need to proceed according to first what is the characteristic equation, like what are the eigenvalues and what is the eigenvectors corresponding that lambda eigenvalues. If the different eigenvalues are there, we need to find the different eigenvector. And sometimes the eigenvalues are repeated, then we need to find out in terms of that arbitrary constant by taking k as any value. But we need to consider what are the different eigenvectors corresponding the eigenvalues. For example, it is also like finally the conclusion of this one. In this matrix, the eigen characteristic equation is like this, and again by solving that, eigenvalues are 0, 3, 15. By corresponding that eigenvectors are we found already. That is a case one. That is a lambda is equal to 0. The eigenvector is 1k, 2k, 2k. Here by taking k is equal to 1, we obtain that clearly 1 to 2. The lambda is equal to 3. We obtain that clearly. That is a 2k k minus 2k. Again k is equal to, we assume that any k1 value, we obtain the 2, 1 and also minus 2. And similarly lambda is equal to 15. We again already completed 2k minus 2k k. Therefore the values is 2 minus 2, 1 is an eigen vector. These are the particular the matrix is order is a 3 by 3. By solving that characteristic equation, we obtain these are the 3 different eigenvectors. Because of here the 3 different eigenvalues, we obtain that clearly 3 different eigenvectors. The 3 cases we need to find out. Yeah, for example, find the eigenvalues and eigenvectors. Here the matrix is like this. For example, this one, I am going to discuss this problem directly with the help of the second method. Because I've already understood that is a type 1, that is of first method, but I am going to give that the second method, that is short method. And here also, as we know that the characteristic equation is nothing but lambda cube and again minus s1 lambda square plus s2 lambda and again minus s3 is equal to 0. As we know that s1 is the trace of the matrix. That means the principal diagonal elements, the sum of the diagonal elements. Therefore, it is a trace is the 2, 2, 2. That means 6. And again, S2 is equal to the sum of the minors of the diagonal. Here, the diagonal elements are 2, 2, 2. The minus means that particularly individually the row and column delete and find the dead value. And finding that the addition of 3 values. That means S2 is equal to first principal diagonal element is like minor is a delete the particular row and column. The rest of the values are the second diagonal element, third diagonal elements minus it is 2, 0, 0, 2. We need to addition of these 3. That means 4, 3 plus 3. That means here also we obtain that 11. And finally that is the 3 is nothing but here we get the find the data of the matrix. Therefore, that is automatically 6 only. By even calculating according to that 2 into that is 4 minus 0 and again minus 0 into something plus 1 into something 0 minus 2. Finally 8 minus 2 is equal to that is 6 is the final value. These are the values we need to replace in the characteristic equation in terms of the like S1, S2, S3 in terms of here S1, S2, S3 we completed. These values can replace in the terminology. Here we need to find out. Here the solving the eigenvalues are 1 to 3. Therefore, here also we obtain the 3 different cases we need to find out further. Like same by using the previous example, we need to find out the 3 cases with the help of the case 1, that is a lambda is equal to 1, and with the help of the lambda is equal to 2 and lambda is equal to 3. And lambda is equal to 1. For example, case 1. Here these are the values. And again, while we are going to observe here properly, the equations are that these are the equations. And here we need to understand. Here the equations are when you are going to observing, we need to take that like the 2 different equations we need to assume. But moreover, in this first and third equations, it is not possible by taking that because of first and third is same equations. Compulsory we need to avoid these are the by taking the 2 conditions like 1 and 2 is 1 and 3 is not possible. Then what is the alternative? Here only the options are Even if it is taking that first and second, by solving that, we get the 0, 0. That means it is not a correct to consider the two equations. Why? Because according to the eigenvector is non-zero eigenvector should be satisfied. And further, we need to take that either the options are only 1, 2 or 2, 3. Because of 1, 3 is already it is collapsed. Because of we need to avoid that third equations or any like repeated one equations. Therefore, either 1, 2 or like 2, 3. And here I choose that second and third. Therefore, x1, x2, x3 clearly. And again, that third equation is like this. By solving this one, x1 by x2 by x3 by, and as it is clearly we discussed in the previous one, x1 means the deleted particular row, and again the rest of that AD minus BC. And again x2 is also divided that particularly that AD minus BC. Similarly, x3 by also we need to find out. And here clearly getting the values are that eigenvector is called x1 is 1, that is a k, and x2 is equal to 0 k, that means 0, and x3 is equal to minus k, that is also minus 1 value. That is a particular eigen corresponding eigenvector. And even here, if we need to observe, here 1, 0, minus 1, or sometimes it is a minus 1, 0, 1 is also no problem. Because of 1, 0, minus 1 is equal to minus 1, 0, 1 also. Both are same. That depend upon k is equal to, we need to assume any values, we get the same solutions. There is no meaning, there is no change of the meaning. And lambda is equal to, for example, 2 value. Again, we need to further, we need to proceed like this. Here also we need to observe that the equation is x is equal to 0. And again, all the values are zeros. And again, x1 is equal to 0. And here also some different type of the problem. And what it is here, while we are going to observe here, that middle of the equation is 0. That means there is no equation. That means it is useless of the second equations. Only the options are first and second, first and third. Here first one is x3 is equal to 0. There is no option. And third equation is x2, that is x1 is equal to 0. That means there is no option. And if it is x1 is equal to 0, and again x2 like x3 is equal to 0 and x1 is equal to 0, that means clearly we understood that is x2 is equal, that is a k be any arbitrary constants. That means either you need to follow according to like this. We are getting that by taking the first and second, because of there is no requirement of consider the second row. Therefore, only options are 1 and 2, 3. Therefore, it is x2 is equal to k. That is because of x1 is equal to 0. Already easily identified from the equations are also that x1 is equal to 0 and x3 is equal to 0. And the x2 is equal, there is no number. That means we need to assume that k in a arbitrary constants. That means we assume that 1 is a value. Or like a 0, minus 1, 0 also no problem. That depend upon the k values, we get the different values of the k values, like different vectors. And similarly, that x3. That k3, that is a like lambda is equal to 3 is eigenvector. Here. And here also some same because of the first equation and again second equation, third equation. What we are going to observe here, it is not given the directly, but indirectly it is also problem is x1 and x3 is equal to both are the same. Because of we need to take out common first equation with minus, then automatically we obtain the third equation. That means while we are going to take that first and third, you get that same the 0, 0, 0. That means it is a repeated equation indirectly. We assume that. Therefore, we avoid that is a third equation or first equation. Then automatically by taking any one of that first and third, you took that only one equation. And again, with the help of that other equation, that is x2. That means combination of either the first, second or second. That is mandatory. We should not take that first and third because of both are the same equations. Therefore, while we are going to solve here that the second and third, as you know that how to find the solutions. It is clearly. And here x1 is equal to k, x3 is equal to also k, that x2 is equal to 0. That means the eigenvector corresponding lambda is equal to 3 is a 1, 0, 1. That means it is a k 0, k is otherwise k is equal to 1, for example 1, 0, 1. K is equal to minus 1, the values are that is a minus k 0, minus k. K is equal to that is a 2, 0, 2 is the values. That depend upon the k values, we get the different eigenvectors corresponding that lambda is equal to 3 is a value. The conclusion of here also the eigenvectors, that is a characteristic equation is we found it lambda q minus 6 lambda square plus lambda 11 lambda minus x equal 0. These are the particular eigenvalues, and further corresponding already we got it, that is minus 1 0, or it is a 1 0 minus 1 also, both are same, or 2 0 minus 2 also no problem. Here corresponding eigenvector is 0 1 0, or it is a 0 minus 1 0, or 0 2 0, that depend upon that k is equal to any taking the values. And here lambda is equal to 3, that is a 1 0 1, or something 2 0 2, that depend upon that any k is equal to any particular real number. And similarly, like any problem is given like this, according to we need to find the eigen vectors. Here first, according to it is a correct equation. Here there is a trace of the matrix, and again est is the sum of the minus of the elements. Like these are the sum of the problems based upon the eigenvectors corresponding that eigen values from the given matrix. Here clearly we did in depth wise also clearly we discuss. We need to check it. Yeah, here clearly based upon this one we need to replace in the equation 1. By solving here we obtain that clearly, like the roots are, this is the like factorization method I did here, but in other options are also that depend upon our choice, we can find the solutions. Any other method, trial and error, or factorization method, or synthetic division, we need to find the solutions. Yeah, here also lambda is equal to 2 comma 2 comma 2. See, in this problem, while we are going to observe here, the lambda is equal to is a 3 times repeated. 3 times it is a repeated. That means we need to find out one particular lambda is equal to is a eigenvalue, what is the eigenvector. Therefore, for example, lambda is equal to, the eigenvector is nothing but, like same, the problem is if you understand something how to find the characteristic equation and find the eigenvalues, corresponding eigenvectors are also based upon this is the conditions. Like same, by taking any first, second, or second, third, or something one third, because of here also the 3 equations are the different equations. Yeah. The eigenvector is 1 1 minus 3 is a 1. That means depend upon the k values we obtain that any different eigenvectors. The conclusion here, not conclusion. Yeah, like that. Like that number of problems depend upon the equations we get the solutions. Like yeah, for example, all these problems we need to find the solutions. A number of problems are in front of us. See, for example, in this matrix, find the eigenvalues and eigenvectors of the matrix. Here, this is a matrix. While we are going to observing in this problem, like in the previous up to examples are like easy to get the problems, but in this problem here somewhat easy to find out, because of here at the time of finding the eigenvalues we need to observe that here the problem is based upon the property of the eigenvalues. Already in the previous lectures we discussed the properties of the eigenvalues from the given matrix, and one of the property it is clearly satisfied. The property is nothing but here the given matrix is the upper triangular matrix. That means the below the diagonal elements are the 0. And based upon this upper triangular matrix, the diagonal elements are the eigenvalues of the matrix. That means without calculating, that means whatever we discussed in the previous problem, that is delta of a minus lambda is equal to 0, that is a lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Either we need to follow with the help of this method, otherwise such type of this is the easy to identify from the given matrix is the upper triangular matrix property. Here also the diagonal elements of the eigenvalues are the given matrix. Here the diagonal matrix are that is a 3 to 5. Therefore the eigenvalues are also clearly that is a 3 to 5. And after finding that, again we need to further according to whatever we discussed previously. Then we need to find out either this is the, here I discussed this is the Gauss elimination method. No problem, that is depend upon the Gauss elimination method. This is the meaning of the Gauss elimination method. It is taking some time based upon the Gauss elimination method. We need to do the easiest the method is by using the equation format. By using the equation format also we get the same solution, and finally such type of this is the Gauss elimination method, we can find the solutions. And finally it is also like this is the somewhat it is a like we need to take the risk like time only. We need to avoid this type of the method. Here we need to give the priority easiest method, that is the equation format. Finally the eigenvector, it is also based upon the other method, that is the equation method, and by using this method also we obtain the solution. Here it is a 100 is the eigenvector corresponding lambda is equal to like whatever the given matrix it is a 2 is a matrix. Yeah, that is a 3 eigenvectors, it is a 1. And similarly like 2 and also same the Gauss elimination method, we need further by using the Gauss elimination method or any other method we can easy to find the solutions. But in my choice the given the at the time of that finding the characteristic equation and the characteristic like finding the eigenvalues and the eigenvectors, that eigenvalues are easiest method is like a short method, that is second method. And again the eigenvector is by using that equation format, that is the easiest method to find the solutions. Even though with the help of this the Gauss elimination method we can find the solutions. It is lambda equal to, and further this is also lambda is equal to 5. It is a Gauss elimination, that is a Gauss elimination method is nothing but a reduced to row echelon form method by using only row operations. Yeah, this is the like it will take some time, but even if we get the solutions, but we need to give the priority for that, that is the equation format only. And finally the conclusion is like this is the this is the values, and here is nothing but eigenvectors only, that is the values. Yeah, these are the some corresponding lambda is equal to 3 and lambda is equal to 2 and lambda is equal to 5, whatever we got it according to this method, that is a Gauss elimination method. Otherwise we need to give the priority for the equation format. Like that any problems in another method, same, just now what did I say, it is eigenvectors corresponding, these are the final conclusions. Yeah, it is corresponding eigenvectors and also eigenvalues. Like similarly these are the some example we need to practice this. For clarification we need to check the solutions, your practice homework. Here the corresponding eigenvalues are 136, these are the particular corresponding eigenvectors. And further again that other examples, like these are the some two repeated eigenvalues, repeated eigenvectors, like different eigenvectors. Based upon that assume that k1 and k2. Here also 0, 0 is a repeated eigenvalues, we need to take that further the two different eigenvectors, like by taking the two different real numbers, that is a k1 k2 any arbitrary constants. Here also the 2, 2 is repeated. And these are the particular methods, like according to so what is that first method and second method. One is a method is a short method, and first method is a briefly, and again the second method is a shortly for finding the eigenvalues and also eigenvectors. Whatever we find according to the shortly or briefly, we get the same solutions, eigenvalues and also eigenvectors. If you want to discuss like if you want a clarification whether it is correct or wrong, we need to check according to based upon the properties of eigenvalues also. Sometimes it is useful whatever we get the eigenvalues are repeated or something like whatever the eigenvalues are correct or wrong, that is the sum of the eigenvalues is equal to the trace of the matrix, and product of the eigenvalues is equal to the data of the matrix. That options are there to verification the eigenvalues are correct or wrong by using the properties of the eigenvalues. Further any clarifications, please give me the reply to this link only. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.